We're shifting focus a little bit here, and I'm actually going to take over for just a second, and we're going to talk a little bit about our academic programs. 3 or 4 years ago, I think it was 2017 to be specific, we sat down with a group of faculty from the University of Maine system, from various campuses here in our home state, and we had some discussions about our approach to academia at large. What would be the best approach for us to work with students? We've been getting inquiries from schools, from colleges, from universities, from students, from professors, and we wanted to consolidate that and come up with a program. And that has evolved into kind of a threefold approach to dealing with academia. The first thing that's noteworthy for those of you who are in academia, those of you maybe teaching or researching, or obviously students as well, is our licensing. Our licensing for those of you, I should say, here in the US, north of the border in Canada as well, we can give you a free license of Global Mapper. We can provide the software for free with certain limitations. You can get the full details. You'll note the URL at the bottom of the screen. But we can give you a license of Global Mapper or of the geographic calculator at no cost. And that would be for teaching purposes, for classroom, lab use, et cetera, et cetera. That program, while it is currently restricted to North America, we're looking at the possibility of expanding that. In the meantime, for those outside of the US and Canada, there is highly discounted academic licensing as well. It makes sense for you to contact us to find out what options are available to you. So don't hesitate to get in touch, and we can let you know how best to deploy Global Mapper within your institution, again, for teaching purposes. It does, as I said, cover Global Mapper. It covers the Lidar module, which a lot of people are requesting now. Included in the Lidar module is our Pixels to Points tool, which is our photogrammetric tool, and also Geographic Calculator. You can access all of those applications, again, for teaching purposes. The academic curriculum is kind of the second focus. Part of the outcome of the discussion that we had with the faculty members was the idea of providing resources for schools and colleges. And myself and some of my colleagues in the technical area came up with a series of workflows. These are free instructional materials that are available for everyone in the academic area. Schools and colleges all over the world can access these. Just again, contact us, let us know. We can provide those to you. I believe there are 9, we're up to 9, and we're continuing to create those to build and develop new materials for academic use. Again, I'm getting ahead of my bullets here. Produced in cooperation with faculty from UMaine, from the UMaine system. And as I said, 9, everything from thematic mapping to drone processing, everything in between. Again, written instructions that will allow you to deploy Global Mapper and allow you to deploy the technology very efficiently. And then a series of exercises as well that your students can perform. So this simplifies the deployment. It allows you to simplify the instruction in GIS as well. You're not spending a lot of time working on the mechanics of the software, spending more time actually applying it in a practical sense. So if you're in an academic situation, by all means, request these licenses, ask for a license and ask for the curriculum materials, and we'd be more than happy to provide those for you. The third arm of our academic program is our scholarship. We introduced this last year. We put out a request for students to provide us some details of some work they've done. We were offering $500. Money is money for a student. I know it's always valuable. I have a student at home and he would love to get $500 towards his expenses. So we were offering $500 to a student that was able to demonstrate proficiency and creativity in their use of Blue Marble technology. We introduced it last year, and at this time last year, we introduced our winner. And this year, it's the same. We are delighted to have the opportunity to introduce the winner of the 2019-2020 scholarship. I'm just making sure that she's online. Kelsi, are you hearing me? Let's make sure her mic is on. Hi, Kelsi. Are we making contact? Hi, Kelsi.
Hi. How are you? Great. I'm excited to
joining us today. How are things in Texas today?
It's going well. The weather is really nice, so it's that very short but sweet period where warm, mild temperatures are here before it gets oppressively hot.
Before
So
the,
trying to spend some time outdoors.
before the humidity kicks in. Excellent. Well, so we had a large number of entries for this program. We reviewed each one of them. Many deserving candidates. I know some of you may be online who submitted one. The group of the committee who made the selection consistently pointed to the work that Kelsi did as being exemplary. And when we were talking about how we're going to introduce her, we thought, well, maybe she could summarize her presentation, just maybe answering some questions. But hey, why not have her actually show it? So in a few minutes, I'm actually going to hand the mic and the screen over to Kelsi, and she's actually going to guide us through her presentation, guide us through the work that she's done. So I'm personally very excited to hear this in the first person, Kelsi, so, and our audience will be as well. Before we get there, just a couple of questions for you. It's always something I'm interested in personally when I hear about people using Global Mapper. How did you first hear about it? How did you first hear about the application?
So I first heard about Global Mapper a couple years ago, and it was actually my husband who recommended it. So at the time, he owned a small business surveying using drones, and they were trying to find a software that was, cost efficient but could handle the large point clouds they were working with. And ultimately, he came to Global Mapper, and he just raved about it, and eventually, convinced me to try it out, and I've been using it ever since.
It's an interesting one. A family recommendation. We'll put that one on the list. We know word of mouth in a professional context is good for us as well, but having spouses recommend our software is also something we should be aware of. Within the software, obviously, having looked at your presentation, you're very proficient. You've got high technical capability within the software, but I always like to ask as well, what's your favorite function of Global Mapper? When you're using it and obviously learning it yourself, what was that, whoa, this is a great tool? What was that part of Global Mapper that appealed to you most?
I have really been using the ground filters and the noise filters a lot, and I think what's really great about Global Mapper is, being able to apply that and kind of tweak those parameters, but then also be able to view it in the 3D viewer mode, so I can actually, look right away as to how accurate I feel like those filters were applied.
Yeah, and
that's been my favorite so far.
Cool. You obviously you didn't have any formal training. How easy was it for you to pick it up? I mean, were you able to learn it very quickly? Obviously, you had your husband to help you.
Yes, he was a big help, but it is so user friendly that, just if I needed help with something, usually I could Google it or find it, or just the interface again is very user friendly. And it really hasn't been difficult at all to learn to pick up on it. And I still have a lot to learn. I've been only using it for about a year now, but as of right now, it's definitely been, one of the easiest softwares to pick up on and learn more about the features.
Oh, excellent. So kind of we're obviously approaching this from under the auspice of academic application. You obviously work with people at the university there down in Corpus Christi. Would you recommend this to others as well, or have you recommended it to others? Have you been an evangelist for Global Mapper?
I have, absolutely. I recommend it, and I already have convinced, our lab has the Lidar module license, and I've already convinced a couple people in the lab when they're working with their point clouds to, import it into Global Mapper and utilize that software. And so we already have a couple more people using it at this point, and I'm sure more and more people will begin to in the future.
Oh, excellent. That's great. So your research was using structure from motion LiDAR and GIS to evaluate hurricane impacts. Anybody who lives along the Gulf Coast of the US here, other parts of the world as well, obviously very important. What motivated you, Kelsi, to study this? What was your motivation behind this field of study?
So I think
Have we lost Kelsi? I think we may have lost her. Let me just check my
largest motivation is, I knew I wanted to be involved in something that would.
I think we may be having a few sound issues, Kelsi. Just could you repeat that? I'm sorry, we missed your answer there. So what was it? What motivated you to apply that, or to embark on this field of study?
So can you hear me okay now?
We can hear you now. Yes.
Okay, so ultimately, I think, climate change and trying to look into ways in which we can help adapt to climate change using remote sensing technology was one of my greatest motivations. And we know that as climate change worsens, it's expected that hurricane or severe hurricanes will increase in frequency. So that was kind of my motivation here to see, okay, well, what are some more efficient means that maybe we can quantify hurricane impacts to help get a better understanding of how our coastal zones might react to them or how vulnerable they are in the future.
Excellent, excellent. Well, let me on behalf of my colleagues here at Blue Marble, congratulate you on your winning of the scholarship. And with that, let's go ahead and switch my presenter here, and you can show us exactly what was involved in your research.
All right, thank you, David. Okay, so we'll go ahead and get started here. And again, my presentation discusses my current research going on, which is using SfM, or Structure from Motion, Lidar, and GIS to evaluate hurricane impacts. And before I get started, I would like to thank my advisor, Dr. Michael J. Starrick at A&M Corpus Christi, as well as Megan Lamb, who is someone we're working closely with at the study site to see kind of what best suits their needs. And a little bit about myself. I'm currently a second-year doctoral student at Texas A&M University Corpus Christi. And before A&M Corpus Christi, I was a student at Texas A&M College Station and the University of Alabama. At A&M Corpus, I'm a member of the Conrad Blucher Institute for Surveying and Science, also known as CBI, as well as the Measurement Analytics Lab, or MANTIS. And this is just one component of my dissertation research, but ultimately, kind of the overall theme of my research involves trying to use different remote sensing data sets, infusing those, as well as the potential of drone technology and machine learning to develop more robust coastal monitoring efforts. And brief introduction here, we already discussed this a little bit, but as climate change continues to worsen in the future, most models generally predict that the frequency of severe hurricanes is also going to increase. So therefore, to help disaster relief efforts, as well as to determine the resiliency of our coastal zones, it's very important that we actually quantify the impacts of the hurricanes. And to do this, ultimately, we need an elevation model from before the hurricane made landfall and then after the hurricane then made landfall. And for the last few decades, typically this is done using airborne LiDAR. However, airborne LiDAR, the sensor, as well as if it's flown on an aircraft, is just extremely costly. And oftentimes this can compromise either the spatial and or temporal resolution of the surveys. So therefore, we wanted to see, okay, well, can we implement as either a substitute or integrate with LiDAR a drone or UAS as a less costly alternative there? And this is the study site. The study takes place at Little St. George Island, and this is one of two barrier islands encompassed in the Apalachicola National Estuarine Research Reserve. And we're working very, very closely with them and trying to figure out what best suits their needs in the future for data-driven decisions to help conserve that environment. And Little St. George itself is located about 14 kilometers off the coast of Apalachicola, Florida. And the big thing to point out here is it is undeveloped. So we're not, assessing anthropogenic impacts. This is simply the impact of Hurricane Michael specifically on this environment. And you can see that box toward the bottom that we looked at a 3.2 kilometer segment of Little St. George. So I do plan on eventually looking at the impacts for the entire island. We have that data, but specifically kind of for proof of concept, we focused on this region of the island. And the hurricane that we have quantified the impacts of is Hurricane Michael. A little bit about Hurricane Michael. They went back and actually categorized it as a Category 5 storm. It made landfall on the Florida coast on October 10th of 2018, and it made the most direct landfall near Mexico Beach, Florida, but that's only about 30 miles from Apalachicola. So Apalachicola and the study site did get hit pretty hard from the hurricane. All right, moving into data taken before the hurricane made landfall. So this is data, or we collected high resolution UAS imagery before Hurricane Michael. In July 2018 is when our survey team went out to do that. And this is the data we collected, and I'll walk through the steps to eventually create an elevation model. But that data was collected using the fixed wing SenseFly EB Plus, as pictured here, and it was equipped with just an RGB camera called the SenseFly SOTA camera. And you want to make sure for structure for motion, which I'll go over here in a moment, that you have overlap for those images. So it was flown at about 98 meters altitude with 80% side lap and 70% overlap. And then in order to actually test the accuracy of the digital elevation model that will be created, we also established a series of ground control points. So those were measured in with an RTK GPS, specifically the Trimble R8S GNSS system. So that was data obtained before Hurricane Michael made landfall, and then I was actually able to obtain this data from after Hurricane Michael made landfall. And this is a 1 meter digital elevation model, or DEM, that I got from NOAA Digital Coast. And I strongly recommend, if you haven't been to NOAA Digital Coast, that you go check it out. They have all kinds of data sets for our coastal regions here in the US that you can get for free and have access to. So this is where I received that. And this elevation model was generated from topobathymetric airborne Lidar that the US Army Corps of Engineers collected in the weeks following the landfall of Hurricane Michael. And this specifically was collected with their coastal zone mapping and imaging sensor and has 0.196 meter vertical accuracy. So you can see I was able to clip just the study area, and they sent that data over to me. So then going back to the images that were obtained before Hurricane Michael made landfall, those were processed using a photogrammetric technique that we call structure from motion, or SfM. And I did this in Pix4D, and I'll quickly summarize how this process works. But ultimately, I import all of those images into Pix4D, and it looks at those images to identify unique features. And at where it identifies those unique features, it establishes key points. And it can pick out those key points from multiple images since they're overlapping, using what they call the SIFT algorithm, or so the SIFT algorithm. And then from that, it can then calibrate external and internal camera parameters. And once it's done that, it can then densify the point cloud. So that's the important step there, is it can identify many more additional key points. And ultimately, that's what allows for the dense output point cloud to be generated. And then ultimately, from that point cloud, we can then later on generate an elevation model. So those steps were taken from Pix4D. That's the process it uses to generate those point clouds from overlapping images. Okay, and I'm going to go ahead and play this video here. This is a fly-through video generated in Global Mapper of the resulting beach and foredune point cloud. And the point cloud itself was actually over 257 million points. And I was really impressed with Global Mapper. So it was quite easy to import that very large data set and filter that and work with it. So Global Mapper was just really powerful in doing that. And this resulting point cloud averaged about 520 points per square meter on the exposed beach and foredunes, and then about 340 points per square meter in that back dune region. Okay, and then moving on to the more challenging part of this research, which is going to be filtering. So I've, always kind of had difficulties with the ground filtration, especially in these beach environments. It can get tricky. So filtering techniques I applied using Global Mapper, But before doing so, it was very clear to me that the back dune region, as seen on the bottom images, very different or varied from the beach and foredunes pretty significantly. So because of those terrain differences, I actually separated them into two separate point clouds. So I had the beach and foredunes, which had similar characteristics and behaved similarly, and then I had the back dunes. And this is so that I could apply the proper filters with, their own parameter settings differently to those two terrain types. And I tried originally applying the ground filter to the beach and foredunes. However, the vegetation at this particular study site is just so low lying there that no matter, I even tried other software as well, is just too low lying to accurately distinguish between what are true ground points and then what are those vegetation or vegetative points. And you can see that if we look at the top left image, that's just a clip of the beach there from the point cloud. And then to the right, you can see that's what that same spot looked like after I applied the ground filter. So obviously it's taking away a substantial amount of ground points. So this is where I just made the decision to not apply the ground filter in that region, hoping that the noise filter would take out, potentially those few points of higher vegetation. However, if you look at the bottom, that ground filter was successfully applied to the back dunes. So these are mangrove species, and you can see that they're higher in elevation. And if you look to the bottom right image, you can see that after that filter was applied, it did a really great job at removing that vegetation. Okay, so that was the ground filter, and then I moved over to the noise filter. And we received a noise where the water or the shoreline met the beach. And this is because structure for motion has a difficult time with water features because water is always moving. So often it's difficult, even just taking one image to the next, the water features will move and change. So often results you'll see in clutter for water features from structure for motion. And also you have issues of a lack of points sometimes, or homogeneity of the beach and water also means that sometimes structure for motion just simply can't pick out those unique features. So if it can't identify unique features in a homogeneous environment, sometimes it results in a lack of features. So you'll see that in the top right image there. But to address the noise that was present, I applied a noise filter in Global Mapper, and it did a really great job at removing much of the noise. And that was applied to both terrain types. So both the foredunes and exposed beach, as well as the back dunes. And that bottom image there is the beach and foredunes after that noise filter was applied. And then moving into quickly the limitations and challenges of using structure for motion. So of course we have the noise, but then also one of the limitations of using structure for motion compared to Lidar is an inability to capture ground points below the canopy. So most laser sensors now are multi-return, meaning if they come into contact with the canopy, it might return that pulse and then continue to penetrate down to where it eventually can reach the ground. However, with structure for motion, because it relies on those unique features, unless you're actually capturing the ground below the canopy from multiple images, it won't be able to identify or map ground features. So what happened is after I applied that ground filter, which worked really well, I ultimately had these very large gaps in the back dune portion, which you can see in the top image. And ultimately those gaps were just so large from so much vegetation that it had to be heavily interpolated. And then again, so you can't really rely on structure for motion to map water features. After I applied those filters to the point cloud, I then had a product I was pretty happy with, without much noise, and from what I could tell, mostly ground points. So from there, using the binning minimum method that was discussed earlier, I actually output a 0.1 meter resolution DEM in Global Mapper. And if you remember the Lidar DEM I obtained was 1 meter. So this allowed us to obtain much higher spatial resolution there. We output a 0.1 meter resolution DEM, and you can see on the bottom image that high spatial resolution really allows you to see the dunes there. And then now onto the tools to actually quantify the hurricane impacts. In Global Mapper, I used what's called the Combine and Compare Terrain Layers tool, which is very, very easy to use. That's what's been so great about Global Mapper during this process is, again, these tools are very user-friendly. And you can see on the right here, this is just an image of that tool and those parameters I'd input there. So this allows you to actually generate a visual of the change per pixel to map the impacts. And because of the issue of the back dunes being so heavily interpolated, I ended up only focusing on the beach and foredunes and using that terrain type in order to conduct this analysis. So I output the results of that at 0.1 meter resolution. And then moving on to the measure volumes between two surfaces. This was the other tool I used within Global Mapper. And this was applied to quantify sediment movement. And it's really great. We'll see here in a moment with the results. It actually breaks it up also into quantifying the accretion and erosion. And again, because of the back dunes being heavily interpolated, I only used the beach and foredunes for this analysis as well. Beginning here with the results of the vertical accuracy, and I got this vertical accuracy by looking at the digital elevation model that was generated using the structure for motion point cloud and comparing those to the ground control points that were established at the survey site. And I want to point out here the mean difference between the UAS SfM DEM was 0.025 meters and less than an inch. And if you remember, the Lidar DEM said 0.196 meters. So this is extremely accurate and definitely suitable for the purposes of quantifying the impacts of this hurricane. And then moving on to the results of using the Combine and Compare Terrain Layers tool. So again, it just outputs this really nice visual for you. And I know that the people working at Apalachicola National, or the Estuarine Research Reserve, are really excited because this is an easy way for them to visualize, where on the island was it most impacted, where is most vulnerable in the future, and if we're taking actions to help try to conserve the island and need to prioritize certain areas, this really allows them to see maybe what areas should be prioritized. So you can see here the red values, yellow and red, represent a loss of elevation. And you'll notice that in the northwestern portion of the island here, they experienced severe erosion in that area. And then you'll also notice that red line running across the island, the study site, and that was the foredune, the original foredune region, and much of those were strongly impacted by Hurricane Michael. Some of them almost wiped out entirely. And then you also can see that there is actually accretion on either side, and we suspect that that's from wave action or, those foredunes, that's the sediment transported from those. And then what's really awesome here are the results of measuring volumes between two surfaces. So this is the output data from that tool in Global Mapper, and it gives you the average change in elevation per pixel, which is 0.169 meter change. And then the greatest change in elevation up to almost 4 meters, which was really substantial. And that was actually that northwestern portion of the island that I just pointed out. So you'll see here in that left image that represents the foredunes before Hurricane Michael made landfall. So using our structure for motion DEM, and then over to the right, that's that same portion after Hurricane Michael made landfall. And you can see that those dunes were, completely taken out, and that region actually inundated in the process. And then it also outputs the total volume difference, which we can see is almost 200,000 cubic yards, and breaks that up further into erosion and accretion. So of that, 137,000 cubic yards were eroded, and about 62,000 were showing signs of accretion. as well as density. So density per cubic yard, 0.8 cubic yards eroded, as well as accretion, 0.364 cubic yards. Coming to our conclusions here, so we ultimately determined UAS structure for motion can provide an alternative to those costly LiDAR surveys, which would be really great at a regional level. So the last LiDAR survey that I found for the study site, freely available on NOAA Digital Coast, was from 2010. So it might not accurately show what the study site looked like directly before Hurricane Michael made landfall. That was an 8-year period, and that can change a lot just naturally. So this allowed us to go out and actually get a better idea of what the landscape looked like prior to Hurricane Michael making landfall, and this method could be deployed at regional levels to have perhaps more reliable results of hurricane impacts. And ultimately, Global Mapper was a very valuable tool for filtering, visualizing, and analyzing those point clouds. I definitely want to point out it's great to have that visualization of how well the filters have worked right there. So I've worked with other software where I'm applying these different parameters for those filters, and I have to import it into another software to visualize it, which just adds, more time. So it was great to use Global Mapper just to get those results right then and there. And as well as allowing us to quantify hurricane impacts, gave us a lot of good data there. And again, so we're working closely with the Apalachicola National Estuarine Research Reserve. This is where that study site's located, and they'll actually be directly using this data in order to try to work on developing data-driven conservation decisions at that site in the future. As well as future work, so we're trying to incorporate using this drone data into more standard protocols as well. So we'll be trying to use this structure for motion derived point cloud and elevation model into what they call the GeoTalks volumetric toolbox. This stands for the Joint Airborne Bathymetry Technical Center of Expertise, which is a GIS toolbox to quantify the volumetric change for within transects, which is their typical protocol for, say, FEMA. And this was developed by the Army Corps of Engineers. So that's also something we're working on right now, and these are results also from that, where it allows us to quantify using both the structure for motion derived digital elevation model and LiDAR derived elevation model, those volumetric changes per transect. So thank you, and if you would like to contact me, my email is kschwind@islander.tamucc.edu. I would also really like to thank our sponsors, NGS and NOAA, as well as our collaborators, both the U.S. Army Corps of Engineers, and again, those folks out at Apalachicola for all their help. And I would like to thank you for listening to the talk, and I'd be happy to answer any questions at this point.
Well, thank you, Kelsi. That was fascinating. It really was. Great to see Global Mapper being used for some of these practical workflows. There have been quite a few questions. I think you're going to be busy answering emails for the foreseeable future here.
Okay.
Let me pull out a few. Somebody asking about control points. How many control points were used?
So for that specific area, the 3.2 kilometers, 15 ground control points.
15 ground control points.
Okay.
Given the difficulty in vegetated areas, do you think structure for motion is an option for looking at marsh change? And maybe not something you've any experience with, but maybe some recommendations on marsh change?
This is where it gets tricky. This is actually part of my dissertation as well, moving forward, looking at its potential in those environments. I think maybe fusing this data with LiDAR data, it has a lot of potential, but ultimately in environments where you're going to have dense canopy coverage, I don't think it's the best method personally. And that's again just because it is very limited on getting ground points in those environments. So if you're looking for a surface model, great, but I'm not sure if it's if it's what you're going to want for a digital elevation model.
Yeah, and certainly in marsh areas that would be a little bit ambiguous. And we've mentioned this many times in our presentations and our training classes. Some of the limitations of the structure from motion, but certainly advantages as well. Cost being a big one of them. In terms of the hardware. Speaking of hardware, question about the drone itself. And I've lost my question here. Oh yeah, well, how much did it? Somebody wants to know how much it costs. I guess there's money involved in everything. So what was the cost of the drone?
Yes. So the drone, the one that we used, the fixed wing, it came with the camera, was about $30,000.
Okay.
And what's really cool about this process though is, yes, that using the fixed wing was great for our purposes because you still can cover, relatively large areas because the battery life I think is almost an hour compared to quadcopters. But even those inexpensive quadcopters you can purchase, online can still be used for the same process as long as you have high resolution overlapping images. There's theoretically no reason why that shouldn't work as well. And in fact, the other few studies I've seen where they try to use drone technology to quantify hurricane impacts, they are using quadcopters, which could be purchased for around $1,000.
Yeah, and that's
a couple thousand.
A question that was asked. You've just answered a question. The next question is about the use of a quadcopter. I think they saw in your slide you were using a fixed wing UAV, but quadcopter obviously would work as well. Maybe time for one more. This is kind of a more broad question. Do you see this? How do you see this research fitting into the bigger picture of I guess disaster relief or resiliency modeling? I mean, this is obviously an interesting study in and of itself, but I'm sure there's an application kind of in a broader context. Maybe you could speak to kind of that. How do you see this applying in other locations, perhaps other timeframes?
Right. I think the great thing about this is just the flexibility. It's much more easy to deploy, and I think because it's much less costly, it could be utilized a lot more frequently. And I think the biggest advantage here is for more reliable impact assessments. So, if we have an episodic storm coming, a hurricane, perhaps rather than having to use LiDAR data that's 8 years old, when the study site has probably changed dramatically in that time period anyways, this would allow researchers to go out and actually map these regions they think are going to be most impacted to have more reliable results. So you're comparing the impacts to what the landscape actually looked like beforehand versus 8 years earlier. So in my opinion, I think it has the application of, yes, just more reliable results in terms of how that hurricane actually impacted the study site.
Yeah, the before and after, and certainly we use a lot of these coastal data sets for some of our workflows. You showed us the comparison tool. I should also mention, just as kind of a segue into maybe some of the new tools that have been added in Global Mapper with the latest release, version 21.1. I think maybe Kat might even be showing this afternoon. We have a change detection function that can be applied directly to a point cloud now. You can actually isolate points that there has been change over a time frame, two different collection periods. So Kelsi, I'm not sure if you're aware of that, but that is certainly something that's available in the current release. Also, it's worth mentioning that for those working with the LiDAR module, the structure from motion is a component in there as well. Our pixels to points tool will allow you to do the structural from motion point cloud generation, again, all directly within Global Mapper. So Kelsi, thank you so much. That was fascinating. A lot of comments about how fascinating your presentation was. So I will reiterate the comments from our attendees, and that was a really excellent presentation. Thank you so much for joining us today.
Thank you so much. Have a good one.
You too.